Today we're going to be talking about charge, discharge, and state of charge as it relates to SimpliPhi batteries. So don't hesitate to jump in with any questions during the presentation. If I can't answer them right away, I will get to everybody's question at the end of the training. I'm going to begin here with just a little bit of background about our company and then how we make our products and what products we offer. It's going to take about 5 minutes, and then we'll jump into today's unique content and talk about charge and discharge and how it relates to state of charge of SimpliPhi batteries. So to begin with a little overview of our company, we were actually founded in 2010 as OES Energy. So we've been leveraging really a decade of experience, 12 years now. So we really began in the mobile industry. So we were making power packs for filmmakers who simply could not deal with the drawbacks of lead acid batteries and the safety hazards of, at the time, the best lithium batteries there were on the market. So we really were founded as a solution to that problem, creating a safer and more reliable solution for filmmakers to use in the field. You will see some of our batteries with an OES logo on the field, remaining in place after their 10-year warranty has already expired, still in use, operating. So that is something interesting to see, is our product's already outliving its warranty, whereas a lot of these battery manufacturers are just now switching over to LFP batteries. We've got some that are over 10 years old. We did, in fact, move into the residential, military, and emergency response space very quickly. The military wanted to use a new type of battery for a project and was not willing to sacrifice for the safety concerns that lithium batteries had to offer at the time. So lithium was off limits for them. However, we convinced them to at least test our battery out at their facility and perform safety testing on it, and they were impressed and did end up using our lithium iron phosphate batteries there. So that was a big step forward for lithium batteries, I would say, is being used in Department of Defense projects and being proven as safe by the Department of Defense. It actually took place, that testing, at Aberdeen Proving Grounds, which is not too far from where I grew up in Maryland. So in 2013, we began to expand our product line, including a wider variety of solutions, really geared toward what the installer needs to get the job done and what the homeowners have been asking for and need. In 2015, we relaunched as SimpliPhi Power, changing our name from OES. And since then, we've really been ramping up our manufacturing capacity at our location in Oxnard, California. We use only lithium iron phosphate chemistry and only cylindrical form factor. This is all we've ever done. We really find that lithium iron phosphate has no concern as far as thermal runaway and causing fires. The heat releases from a lithium iron phosphate battery and thermal runaway so slowly that there's really no concern or possibility for it to actually cause a fire. And as far as cell form factor, pouch cells can be a little bit less durable in terms of puncture and being vibrated a whole bunch. There's no rigid case around them that can hold a mass amount of pressure from the inside or the outside. Prismatic cells are great, but we found that cylindrical cells have the most rigid casing and last the longest. So in terms of the products we offer, we now do have a pretty wide range of products. So I'm going to go through all of them here, just briefly though. First off, our most popular product is our Phi battery. This is a simple parallel connection, so it's not to be series connected. It is modular and scalable, so it's really made to be a lead acid drop-in replacement. But honestly, it's used for all sorts of projects nowadays. It is available in 24 and 48 volts, and it has an integrated internal battery management system that not only balances the cells but keeps them safe, and of course, an integrated circuit breaker on the top for protection. Now, this is something I'm not seeing with too many other batteries. I find that having a circuit breaker built into the battery is just so essential and make everything so much easier. It also saves you a step or two as far as having to install an external DC disconnect for your battery bank. Instead, you just have it already there. Now, this is compatible with a wide range of equipment, right? That's why we call this a drop-in lead acid replacement, is because you can pair this with just about any inverter or charge controller, as long as that inverter or charge controller allows you to program custom set points as far as battery charging and discharging goes. We also offer very similar product in a smaller size. So this is a 1.4 kilowatt hour coming in 12 volts or 24 volts. This battery now does have a breaker integrated and terminals on the top. It's scalable, so really with this and with the 3.8, you can parallel as many as you need. I've seen people parallel up to 100 of these batteries. This battery specifically is small and lightweight at 33 pounds, whereas the 3.8 is weighing in about 86 pounds. So this is a better fit for mobile applications where maybe you need 1, 2, 3, 4 of these guys, not a giant battery bank. It's also still compatible with a wide range of standard inverter and charge controllers and other equipment. The next product I want to talk about is our access unit. So this is a mobile, not mobile, an outdoor rated NEMA 3R enclosure. So this is ready to sit outside, ready to withstand rain, heat, sun, wind. It is able to be installed just about anywhere. I've seen them in garages and I've definitely seen them on outsides of homes. The main selling point here is that we've already got an industry-leading inverter mounted inside the cabinet for you. So really there's very minimal installation to be done. The wiring is already completed within the inverter, so you just need to make those final AC and DC connections to the batteries. This works with new or existing PV, so it's able to be AC coupled or DC coupled. And as with all of our products, there is no maintenance. One of our newer products is our AmpliFi Battery. This is really the same dimensions and electrical specs as the 3.8. However, this is now the same battery with closed loop communications. So there's no external cards required for inverter integration. Really, you're just plugging in a standard Ethernet cable to the inverter and going from there. It's ready to go. You are limited to 75 battery modules in parallel, as there is a Cat5 cable connecting them. And after a certain distance, the signal between the batteries is just not as strong. So you're limited to 75 batteries in parallel in this type of system. Now this allows you to integrate our battery with solar converters, SMA Sunny Island inverters, and our new inverter, the SimpliPhi ESS. What is going to happen here is many of the battery related set points are going to auto populate so that the inverter is going to know how large the battery bank is, how quickly it can be charged, the charge voltages and low voltage cutoffs, etc. This will give you a much higher level of protection because now you not only have the BMS inside the battery, but you also have that BMS talking to the inverter and telling it how it wants to be treated. This gives you a high level of accuracy for readings such as state of charge, voltage, and charge and discharge amperage. Not only are you going to see live readings on the screen of that inverter, but you'll also see the live readings in your portal, your online portal for whatever inverter you're using with it. And you'll see the historic readings, fault codes, etc. So it's a lot more troubleshooting capability and remote monitoring capability there. Another thing we're going to talk about a little bit today is sizing a battery bank. So with the Phi batteries, with any inverter, you will have some minimum number of batteries that you are required to install to prevent that battery bank from discharging or charging too quickly. With the AmpliFi battery, you don't have the same limitation. So as long as the AmpliFi battery is communicating with the equipment, then the equipment's going to know how quickly it can charge the battery. Our newest product is the SimpliPhi ESS. So this is an entire vertically integrated solution. This is coming from our factory floor. We are making now a battery that is much larger. This is a 4.98 kilowatt hour battery, and coming with it is a 6 kilowatt inverter. These two are going to communicate intelligently, and then what you're not seeing here, which would come with a system, is a gateway. So you'd have a gateway which would take all the information from that inverter and from the batteries and upload it to the mobile application where you can program your system, monitor your system, remotely change settings, check for firmware updates and push firmware updates over the air, check on fault codes and warning codes, all these things that you can do without even leaving your home to actually drive to the customer's site. So this is our newest product, and now we're going to talk about how it relates to charging, discharging, and how you can understand the state of charge of your battery bank. So we're going to begin with charging characteristics. And again, feel free to put any questions into the Q&A bar at the bottom or top of your screen. As far as charging characteristics, our batteries are rated to charge and discharge at C/2. So really what this means is you can take, the easiest way to do it is the amp hour capacity of the battery. You just divide that by 2, and that is the charge and discharge rate of that same battery. So for example, the 3.8 kilowatt hour 48 volt battery is a 75 amp hour capacity. You just divide 75 by 2 and you get 37.5 amps. Our 24 volt battery is 151 amp hours. You're going to divide that by 2, you get about 75 amps DC. So on and so forth. All of our products have the same charge and discharge rate, so it's very easy to figure out. For example, our new battery, it is about 5 kilowatt hours. You're going to divide that by 2. The discharge rate is 2.5 kilowatts. So there's plenty of ways that you can figure out the maximum charge and discharge rate of the battery. And these are the continuous rates. This is not a surge capacity. When we compare this to something like a lead acid battery, lead acid are going to charge and discharge at around C/10, sometimes as low as C/20, and if you're really pushing it, maybe C/5. One thing to keep in mind is if you have multiple charging sources on a system. So let's say you've got an inverter that charges at 6 kilowatts, and then you've also got a charge controller that takes solar power and converts it to the correct battery voltage and charges it at 2 kilowatts. It is entirely possible, unless you've disabled that feature, for both of those devices to charge at once. So unless you're able to cause those two devices to communicate and make sure they don't charge at the same time, you're going to want to make sure you have a battery bank large enough to handle that full 8 kilowatt charging capability. So it's very easy to limit the charge rate on charge controllers. Every single one of them has this capability where you can go in, well, I'd say every single one, not if you're using a 20-year-old PWM charge controller that was $10, But beyond that, almost every charge controller on the market today has the ability to limit its output current to the battery. So you can go in and program on the device and decrease the output amperage going to the battery. That's very easy to do, and it's very reliable. The charge controller basically never fails to meet this requirement. Whereas inverter chargers, you definitely have the ability to program some of them to reduce the charge rate, though not all have this capability. And I would argue that depending on the layout of your system, if you've got an AC coupled PV array, some of the inverter chargers just are not reliable in actually following the programming that you've put into the charge rate. So I would say it's highly dependent on your equipment as far as how much you can trust that charge rate. Easiest way to do it here is to just use a battery bank that's sized to handle the maximum charging current of that inverter, or use an AmpliFi battery with a communicating device. So let's talk about voltage. Voltage can be a little confusing with lithium iron phosphate batteries and state of charge as well, really with all lithium batteries. But when you're using a charge controller, you want to make sure to program the bulk and absorb voltage. Usually it's 56 volts flat for 6 minutes as far as an absorb timer. You don't want to be absorbing for hours on end. Now, another thing you can do if your device does not have an absorb timer is to set the end current. So as soon as the charger drops below, let's say 2% of your amp hour capacity of your battery bank, you're going to want that charger to turn off. So for example, let's say you've got a 300 amp hour bank. You would want that charger to turn off when 6 amps or less are going into the bank. So once your batteries are fully charged at 56 volts, that charger is going to turn off. And what's going to happen is you're going to be confused because the voltage is going to immediately drop from 56 down to about 53.3 volts. That's where our batteries sit usually when they're completely full and there's no load on them or no charger on them. So keep in mind, it doesn't mean they're going to sit at 56 volts when they're full. Another place they may sit is they may sit at 54 volts. The reason being here is if you've got PV coming in, we recommend programming that float voltage of your charge controller to 54 volts. Now, I would not bother floating your batteries if you're on grid, because if you are grid connected, using the electricity from the grid just to keep the battery topped off it's just a waste of energy. It's really not needed. The batteries don't discharge quickly on their own as a lead acid would, and they really don't require a float charge. So if you've got additional renewables coming in, you might as well use them and float that battery. Otherwise, don't worry about it. This is a great question. For LFP batteries, are the absorb and bulk equal? Yes, they are. Definitely they are. So as far as inverter compatibility and charging, the voltage set points can vary a little bit based on your inverter. For example, certain manufacturers, we may vary the bulk or absorb voltage by as little as 0.4 volts, so 0.4 of a volt. So we do have integration guides on our website that show you the exact voltage to program everything to, depending on what equipment you have. Really, that 56 volts at 6 minutes is what we're going to go to with just about every manufacturer for the most part. There are a couple exceptions where we're varying that just a little bit. If you're going to be using an inverter charger, I would definitely recommend checking that it has, firstly, the low battery cutout set point that is required to be 48 volts or higher. And I would check that they actually warranty their product for use with lithium batteries. So if they do not warranty for use with lithium batteries, kind of just should explain right there that maybe it's not the best fit. some of our, I would say, most respected installers, they go as far as to charge each battery at their shop with simply a wall plug-in charger before taking it to the customer site. I think this is a great idea because your customer starts out the day with a fully charged battery. If you're familiar with transportation regulations, we're only allowed to ship batteries at 20% state of charge. So unfortunately, our batteries are not going to arrive fully charged at a customer's home. So one thing you can do here, when you're looking for an external charger, I would just contact us. That's the best way to make sure your external charger is approved for use. Many of these available on Amazon are e-bike chargers that are going to bump that voltage way up to like 59, almost 60 volts. That is not a great idea. So make sure to contact us and we can check out any charger you're intending on using and making sure that it's approved. I know Victron Energy makes several highly programmable chargers like the IP chargers. Sadly, I think they are 24 volts at their highest. So make sure to check those out if you've got a 24 volt battery. As far as 48 volts, there is an IOTA charger available as well through most of our distributors. So if you need help finding a charger, let us know. Awesome, so let's move on to discharging characteristics. What I'm wanting to demonstrate here is really just the discharge curve of our batteries. So as you can see, it starts out quite high at 53.2. Now, as you're putting a load on that, you're going to notice the voltage really does not drop all that significantly until you get past, well below 52 volts here. So this is the 52 volt line, around 25% state of charge. And then finally, that voltage just begins to plummet. So realistically, it's super hard to tell what the state of charge is at any given voltage because it depends on the amount of load you have on the battery as well as just how accurate your voltage reading is. There's a much better way to estimate battery state of charge, and that's by measuring current in and current out over a charge cycle. So we'll talk about that. This is a much better demonstration here. It just shows you how flat this curve is, right? So between 52 volts and 51 volts, we've seen a 1 volt drop is equating to about 70% state of charge difference. Man, on a lead acid battery, that'd be more like 4 to 6 volts for a 70% state of charge difference. So having only a 1 volt window makes your voltage reading not tell you all that much about the battery state of charge. For example, let's say you're at 51.5 volts and you've got a C/2 load, that could really be anywhere from 60% to 30% state of charge. So you gotta not only know how much load, but you gotta have a good understanding of this chart. It's a whole mess. You need a battery monitor instead. It's going to measure the current going in and out of the battery at all times and calculate that state of charge for you. Our discharge ratings are the same as our charge ratings, still C/2. So again, take that battery bank amp hour capacity and divide by 2. And this does scale up as you add batteries to the bank. So let's say you've got a 300 amp hour 48 volt bank that can discharge as a whole at 150 amps DC. So each battery is providing this 37.5 amps. We've also got a discharge surge for up to 10 minutes. This is 80 amps DC on our 3.8 kilowatt hour battery. It's even higher at 100 amps DC on our AmpliFi battery and as well on our new ESS SimpliPhi battery. Realistically, I rarely see these surges being used for more than a couple of milliseconds to start a well pump or a motor for maybe a saw. So unlikely that you're really going to be using these in a residential application. This is honestly more geared toward maybe businesses that have peak power demand charges and they just need to shave off an extra amount of power for a couple of minutes here and there. Now, a lot of our customers, they have a large inverter that they barely use any of the power of. So let's say they've got a 6 kilowatt inverter and they only really use a 2 kilowatt load. So they're saying, well, SimpliPhi is going to require me to install 4 batteries on this 6 kilowatt inverter, but I really only think I need 2 batteries. So what they'll try to do is limit the discharge using a breaker for overcurrent protection. We're going to talk about this. I'm not saying that it's never possible, but I don't think it is a good idea. So let's talk about one example here. We've got a 3.8 kilowatt hour system with two batteries. Excuse me. So we've got a 48 volt system with two 3.8 kilowatt hour batteries. So this brings us to a max discharge of 37.5 amps DC per battery module. That is a total of 75 amps DC for the battery bank as a whole. Now, you would want to use usually a 60 amp DC breaker on this type of system. The reason that I don't love this idea is because every breaker is different as far as when it's actually going to open, when it's going to blow, and in addition, this also prevents your customer from utilizing their 10-minute surge. So if they do need to start a well pump or a motor, their breaker is almost definitely going to pop. So let's talk about this a little bit in more detail. Some other options here are using grid support or generator support. So what you can do is program, several different inverters have this feature where you can program the generator to auto start as soon as the load reaches 3 kilowatts, for example. And you can do the same with the grid. Depends on your equipment's capability to actually do this. When I say every breaker is different, this is what I mean. This specific 60 amp breaker is going to open when you're at about 115% of the rated load. So let's see, 60 amps times 115% is 69 amps. So at 69 amps, that's when this breaker is going to open circuit, and it's going to take about 500 seconds to do it. So about 10 minutes. For example, though, this breaker claims to open circuit exactly at 100% of the rated load in as little as about 5 seconds. A little bit hard to believe, but that's a nice breaker. Now, this fuse is not going to open circuit until you're at about 140% of the rated current, and it's going to take, again, up to maybe 10 minutes to do that. So if we're looking at 140% times 60 amps, that's 84 amps. This would not be an applicable fuse to use for overcurrent protection for that style system. So that's why I say that this is not always a good solution. It requires a lot of research and things can vary. The best solution is just sizing your battery bank to meet the needs of the inverter charger and charge controllers. Again, still looking at discharge here, let's talk about what's known as the knee. So this is when the voltage begins to stop being so stable in the middle range of the battery state of charge, and then towards the end, it's going to really drop off steeply. So we're looking at this point here where the battery voltage is going to just plummet. So if you've got a very small load on the battery, you may notice that this happens a lot slower. But let's imagine you've got the largest load possible. You've got a C/2 load, and your battery is approaching 0% stated charge, which corresponds to 48 volts. As soon as your battery hits that 50.2 mark, it's going to really start decreasing in voltage a lot faster. And then as soon as it hits that 48 volt mark and it's at 0, it takes very little time to plummet from 48 volts all the way down to 0 volts, completely empty. Very little time. So you've got to be careful here. You don't want to set your low battery cutout too low. The BMS does have protection for this, but again, if you've got a large load, then you can draw the batteries down so quickly that sometimes the BMS isn't even able to catch it, especially if this is a repeated thing where you're doing it over and over to the batteries. One way to avoid this issue is by setting your low battery cutout to 50.2 volts. If you're not able to do that, you can set your generator to auto start when your battery reaches 50.2 volts and set your low battery cutout as low as 48 volts. 48 volts is really the absolute minimum low battery cutout that I would recommend for our batteries. If you're going below that, there's a very good chance that you could damage those cells, especially if it's a repeated event. Now, let's talk about state of charge. I know we talked a little bit, but it's a touchy subject here. Again, going back to kind of our earlier charts, the voltage is going to greatly vary depending on whether you're charging the device or if you're discharging from the device. So if you've got a single battery at 50% state of charge, you start charging it at C/2, its voltage is going to rise to, let's say, 54.5 or 55 volts even. Now, that same battery at 50% state of charge, you begin to discharge it at C/2, its voltage is going to drop maybe to 51.5 or 52 volts. So keep in mind that the state of charge or discharge is really going to affect whether that voltage sits higher or lower than it would normally. Now, if a battery is just resting, we call that resting state of charge when it's not powering a load and it's not being charged. So this is really its true voltage. If you are integrating a battery monitor into your system, you're not going to have to worry about all this voltage readings changing based on load or discharging. It's simply going to take care of this for you, make all the calculations, and report to you an easy to understand percentage remaining in your battery. This is going to act like a fuel gauge. So our AmpliFi batteries do have this built in inside of the battery. The BMS will take care of these readings and report them to your inverter. So you have to use, a communicating inverter to get these readings out of the battery. Whereas our standard Phi battery, it does not have this capability. There's no such battery monitor inside the battery, so you're going to need to add an external battery monitor and then program that monitor accordingly. So one good monitor is the Victron BMV712. This is really what we've found to be the most accurate for our batteries. It's made for lithium. Whereas when you're looking towards, if you have an Outback system, we've seen a lot of customers using the Outback FlexNet DC battery monitor. This is made for lead acid batteries. Now, I'm not just saying this to you. Outback will explain it themselves. It's just not made for lithium batteries, so it's not the most accurate with that battery type. Again, just explaining here, it's so hard to tell the state of charge from just reading the voltage because let's say you look at a battery voltage and you see 52.7 volts. Now that could mean that you have a C/3 discharge rate and a battery at 50% state of charge. It could also mean that you have a C/2 discharge rate and a battery at 70% state of charge. It could also mean that you have a C/5 discharge rate and a battery at 30% state of charge. So this is why the load or charging speed really impacts the way that voltage is going to sit. So this also kind of influences your set points. A lot of customers are asking us, how do we set the rebulk voltage? Really, it depends on your preferences. I often see them as low as 51.2 to as high as 52.8. I would say that it depends. If you want to be keeping your battery more full all the time, use 52.8. So it'll initiate a charge anytime your battery drops to 52.8. If you want to do less charge cycles, then let your battery discharge a little further and let it go to 51.2. Now, I personally have my system at 52.8 because I like to keep it full. Again, also what's going to affect this is the size of your load. If you've got a very small load, you'll notice that your battery won't drop to 51.2 volts until it is maybe at 20 or 30% state of charge. Whereas if you've got a very heavy load, that battery's easily going to reach 51.2 at around 50% state of charge. So this is why it's important to have a battery monitor. Another question we often get is, as far as cell voltage, where should I set the cell voltage for my system? Well, it depends. Do you want to keep your battery more full, or do you want to sell as much power as possible? So often we see customers at 53.2 on their cell voltage. That's keeping the battery quite full and might reduce the amount of power you sell slightly. Whereas at 52.8 or 52.4, that battery's trying to pull in as much power as it can and push it back out to the grid. So it's really just based on your preferences. Now we're almost done for today. I want to leave time for questions, but I also wanted to talk about our IQ installer program. So if you're already installing our batteries, joining our Elite IQ program is really a no-brainer. What we're going to do is we're going to put you on this map. So we're going to display your business to our customers who are coming to us looking to get products installed. We're going to say, hey, take a look at this map. Here's where you are. I see 3 IQ certified people near you. I know this installer just did an off-grid system that looks a lot like yours, etc. So this is a great way to drum up new business in terms of SimpliPhi customers specifically. In addition, we're also going to be paying cash back for each battery you install. So just for joining the IQ program, you're eligible to get $25 back per battery you install. This program's currently running to the end of July, but we do hope to extend it. And additionally, a photo contest. So send us your photos. We can give you up to $250 for winning our photo contest. That comes in a credit towards future purchases. This is what we're really looking for in our photo contests. We're looking to see your face as well as some products. So if that's possible, send us a team shot of all of your employees and yourself, putting these products in. If you can't, equipment photos like this, really clean installs are always great. They make for a great feature in a newsletter. And I will say, our newsletter goes out to thousands of people each month, and the featured installations are always the top photos. So this is not only a good way to win $250, but it's a great chance for exposure to new customers. You can apply using this link. Really, I would just recommend you email me. So email me here at training@simplifypower.com, and I'll get you set up as a member of the IQ program. This is also the email you can send requests for NABCEP credits, and I'll get those out to you. Please be patient. It does take me sometimes as much as 48 hours to get all those out. Awesome. Well, I'm going to jump into the Q&A and see what questions we've gotten from all you guys. Thanks for jumping on today. How many inverters can be stacked? That's a good question, Gary. Which inverter specifically are you referring to? I know our new ESS inverter, you can parallel 9 inverters, and you can do 120 or 240 split phase. Right now, we're not doing 208 with that inverter, but we hope to in the future. Does that answer your question, or were you looking at a different inverter? I see a raised hand. I can't unmute you, sadly, but if you put your question into the Q&A section, I'll make sure to get to it. Do we just divide by 2 all of those voltages for a 24-volt system? Yes, exactly. And then even divide them by 4 for a 12-volt system. So great question. The amperage values would usually double, though. So keep that in mind and check the spec sheets for amperage values. I cannot send you the PDF for the training, but we will automatically send out a video recording of this training. Is it possible to parallel a 3.5 kilowatt-hour Phi battery with a 3.8 kilowatt-hour Phi battery? It's a great question. It is totally possible. It happens all the time. I think it's a great idea in terms of cost. It's much cheaper to add to a system than it is to have to replace the whole system. Now, the only downside here is that our warranty will revert back to the length of the warranty remaining on the oldest battery in the system. So, meaning if you've got 3 batteries in there and they're 3 years old, and then you add 3 more, the brand new batteries are going to only have a 7-year warranty remaining out of their possible 10-year lifespan or 10-year warranty lifespan. So keep that in mind. It is a little bit of a bummer, but at the same time, we are one of the few manufacturers that specifically allow for system expansion over time. So that is an advantage as well. What is battery state of charge at 52.5 volts? I think we kind of covered how the load as well as the possible charging impacts what your voltage is going to be at any given state of charge. So it's not possible for me to answer that question without more information. And really, you should be getting a battery monitor for your system that's going to keep track of the percentage state of charge for you. Again, I cannot put your hand down. Just make sure to put your question into the Q&A section. All right, well, I don't see any new questions coming in. Thanks everybody for joining today. Again, send me an email if you need NABCEP credits, and I will see you next time. Thanks everybody.